Algebra 2 Honors 10.2 Day 2 Notes. Still looking at independent and dependent events. And so in this first example, we're comparing independent and dependent events, and we have a bag that contains marbles, and you're going to randomly select 3 marbles from the bag. And you have 10 red and 5 blue. So you replace, in part A, you replace each marble. Well, that is going to create these events to be independent. And so the probability that all 3 are blue is going to be the probability that the first is blue times the probability the second is blue times the probability that the third is blue. There's no conditional probability here because you're replacing, and every time you go to grab, it's just as though you were grabbing it the first time. And so you get a 5 out of, there's a total of 15, and that's the probability on each one of those. Those reduce, they reduce to 1/3, and 1/3 cubed is 1 out of 27, and that's about 0.037 or 3.7%. In the next one, you do not replace each marble. That is going to be dependent probabilities. And so in that case, the probability all 3 are blue. The first one is just probably the first is blue. But then that's going to be times the probability that the second is blue given the first is blue, which changes that probability, and then that the third is blue given the first 2 were blue. And that is just that the first being blue is 5 out of 15. You don't replace, so now there's only 4, and there's only 14 in the bag. And then lastly, there's only 3 to choose, and there's 13 in the bag. And if you multiply that out and simplify it, it's 2 over 91, which is about 0.022 or approximately 2.2%. And then they have this compare the above probabilities. And so it's just a method that of how they compare it, that they want it. They just want you to get how much more likely it is to get 3 blue marbles when you don't replace than when you do. And that is just the ratio of your first probability to your second. And that comes out to 91 over 54. And that as a decimal is 1.685. And so you're 1.685 times more likely to select 3 blue marbles when you replace each marble. Before selecting the next. And that's how they want you to compare them. All right, then we have these table to find conditional probabilities. And a quality control inspector checks for defective parts. The table shows the results of the inspector's work. Find the probability that a defective part passes. So right here, they are telling you it's defective. And so it's given it is defective. And so you ignore the non-defective. So it's as though that row does not even exist. And so the probability that a defective part passes is 5 out of that row of 5 plus 24. So it's 5 out of 29, which is approximately 0.172 or 17.2%. In part B, find the probability that a non-defective, so again, only look at the non-defective, and that the non-defective pass is 208, and the total of non-defective are 208 plus 9. So it's that 208 out of 217, and that's about 0.959 or about 95.9%. Writing a rule for finding conditional probabilities. You already had this formula earlier. Of course, they wrote it like this. They just switch sides. And they want you to solve for the conditional probability, which is the probability of B given A. That is your conditional probability. And all they did is divide both sides by the probability of A. And this is kind of an interesting little point. Note that when A and B are independent, this rule still applies because the probability of B is no different than the probability of B given A. When they're independent, if event A happens, it doesn't change the probability of B. So those two are exactly the same. Anyway, finding conditional probability. At a school, 60% of students buy a school lunch, only 10% buy lunch and dessert. What is the probability that a student who buys lunch also buys dessert? So this is the given, is that they buy lunch. So that is going to be your event A. So that's the process that you want to pick it. And then given that they buy lunch, that they also buy dessert, so event B is buys dessert. And so if A is buying lunch, that probability is 60%, change it to a decimal, 0.6. And they told you that 10% buy lunch and dessert, so that probability is 0.1, 10%, 0.1. Use the formula to find probability of B given A. Well, probability of B given A is the probability of A and B divided by the and so it's divided by probability of the given, which is the probability of A. And let's see. So in that, probability of A and B is 0.1, and the probability of A is 0.6. So that is 1/6, which is approximately 0.167, which is about 16.7%. So try this again, just in an extra example. See if we can do the setup here. At a clothing store, 75% buys pants, only 20% buy pants and a belt. What is the probability that a customer who buys pants? So again, this is my given. So that's going to be event A is buys pants. Also buys a belt. So event B is buys a belt. Well, probability of A given that B has occurred is the probability of A and B divided by that probability of A. Whoops. I just wrote this wrong. Sorry. Probability of B, given that A has occurred. My fault. Is all over the probability of A. There we go. And so they give you that 20% buy pants and a belt. And the probability that they buy the pants is 0.75. So that is 20 over 75, which is 4/15, which is about 0.267 or 26.7%. And then another couple of examples I added in to help with the homework. This is why I say you need to know your formulas. If they say events A and B are independent, you should be going, oh, probability of A and B is the product of their individual probabilities. And then plug in what they give you. They tell you the probability of A and B is 0.12. You're to find the probability of A. And the probability of B is 0.2. So if I solve that for the probability of A, just divide by 0.2. And you get 12/20, which is 3/5, which is 0.6. And it's not an application. They won't say about 60%. That they're just going to say 0.6. Okay, events A and B are dependent. That is where you want to use either the rearranged one that we started with here or just this one that we originally learned. Probability of A and B times the probability of B given that A has occurred. And they tell you that this probability is 0.25 and ask you to find the probability of A. And this is 0.4. So that probability of A is going to be 0.25 divided by 0.4, or 25 over 40, which is 5/8, which is 0.625.